Hi guys, how are you all? Hi Shreya, hi Harshita. Maybe you know what? Johan did not join.
Miss Priya,
Yeah,
I'm not sure if my mom texted you, but I have to leave a little bit early for my volleyball game.
told me ma. What happened? Why did give me 1 minute. There are some kids that are missing. I don't know. I should have messaged. Give me a minute. Please. Guys, we'll give another 1 minute for people to join. I think they are 7:10 I gave them. Uh, you're going to give me a minute, okay? I said we'll start at 7:10, right? So in the meantime, I just want to fix something as well. Let me fix that and come back. Mm, send this. There are many people who are joined. Okay, we'll get started. Beyond Prisha, Ananya. Hi. Okay, let's get going. So, what was the last week that we did, and any questions there? Any questions that you had? We did part one and part two of postulates, right? Last time when we met, did we do? Hey, Johan, I'm sorry, Johan. Your mother was the only one who didn't get the welcome email. I'm sorry about it.
That's
Please. Okay. But I did forward it to all the three email IDs just now. Okay, you know why it was a checkbox in the form, right? When you filled up algebra, I copied your name into algebra one class, but not here. I'm sorry. That is the problem. Okay, I'll talk to her.
right.
Yeah. And yeah. Prisha, good to see you. How are you?
I'm good. How are you?
Good. Okay. Um, what are they teaching in school, guys? Have you started school? Have you started school?
We started school, but we're not. I mean, our first unit is like the basics of geometry. We didn't start it yet. We're gonna start in like on Monday.
Next week, okay. How about who else would have joined? Prisha, are you learning geometry in school?
Yeah, I am.
Okay. Did they start?
This week we were doing like distance and we were doing square roots and stuff.
All right. Okay. See, that's what I revised in the last class. We revised a little bit of midpoint distance, radicals, and stuff. Along with that, we went to postulates. Did you guys get to work on the postulate assignment, guys?
I did.
Okay, you did. Okay, so part 1 and 2 you covered. I just want to make sure where we are. Okay, so algebraic proofs. Give me 1 minute. Oh yeah, we didn't do this.
Miss Priya had a question on another assignment other than the postulates.
Okay, can we do at the end today?
Sure.
So Priya will have to go soon as well. So let me finish what best I can. I really want to revise midpoint distances nicely. And radicals, where are we? Do we remember everything? I want to make sure. Okay, coming to radicals, right? You should be, when we start geometry, you should all know operations and radicals, which we did in the summer, but some of you weren't there. But I would like to see how you all do as well. Let's see. How about this one? No. Square root of 24 plus 3 square root of 6. What is the answer for this one? Number 1. Quick, ma. We are just, yeah. So, Prisha, if you need help, you have to let me know. You know how to do, ma, Prisha?
No, I know how to like simplify, but how do you like add them?
It's like, see, root 3, you can consider it as x, root 2 as y. If you have this, right, you can add the two like terms. 3 root 2 plus 1 root 2. Make sense? Come on, guys. Let me see. You're going to send it in chat. I'll give you 1, 2, 3, 4. All 4 operations I'll revise very quickly. 2 root 6. Good job, Ananya. Johan, okay. Dhruv, okay. Harshita, good. Avyukt, good. Oh, Avni, you don't know. Okay. 5 root 6. Pratika, good. Okay. You all got it, right? Prisha. Okay. Shreya, you got it, ma?
Yeah, I'm sending.
Okay, ma. I'm just waiting on you. You have it? Okay, how about this? So addition, subtraction, that's how it works. Coming to this one, how about this? Square root of 6 times square root of 3 times square root of 2. Can you simplify and let me know what is the answer for this one? Because radical operations is the building block in geometry initially. Okay, let me get the more questions ready on that midpoint. What is that I wanted to raise? Midpoint distance and what problems? This one. Let's see. I want to give you some problems. Let's see, guys. I don't have an answer on that. Okay, how about this? Let's see. Okay, done. Shreyas. Oh yeah. Correct the Dhruv, correct the Harshita, Avyut, Johan. Okay, you're all good with this. I'll move on. Can you do this one? Yes, I can do that one. Okay, in multiplication, Prisha, Pratika, I want you to listen. What can I do? I can combine them. 6, 3, 2, 2. Multiplication and division, you can combine them into a single square root. So here, when you expand it, 3 times 2 times 3 times 2 times 2, right? For every 2 copies of the same number, you bring it out. So 1 3 and 1 2 comes out. They are multiplied. Inside, you still have that 2 that is unpaired. It does not have its pair. So this becomes 6 root 2. Did you get it, Prisha and Pratika?
Yeah, I just forgot how to do it.
No problem. Prisha, did you get it?
Yeah, I got it.
Okay, so when it is multiplication division, you can bring it under the same square root. How about if I have root 26 by root 13? What is the answer? Root 26 by root 13. Here you can bring it under the same square root. That symbol is called radical. Whatever is inside is called the radicand. That's right, Johan, Harshita. Yes, Harshita, sure. Thank you for the message. Shreya, I'll definitely record the class for you, Ma. You can come back and listen as well.
Okay, thank you.
Yeah, that's correct, Ma. That's correct, Harshita. Can I move on, guys? I didn't get some answers. Prisha, can I get your answer? Yeah, you got it. Okay, root 2. Correct, Ma. So if it is a division, you can do this. But one another thing that I did want you to remember is in geometry or going further in mathematics, whenever you get an answer like this is definitely incorrect because the denominator of a fraction can never be rational. Okay, if suppose you end up with an irrational denominator, you will have to rationalize the denominator and tell the answer. How do you rationalize the denominator? 1 by root 2 if you have, for you to rationalize it, multiply by itself in both numerator and denominator. You are being fair to the number. However, root 2 times root 2 becomes 2. So the answer becomes root 2 by 2 where your denominator is completely rationalized. So whenever you have a fractional answer with fraction in the denominator, you will have to rationalize it, and for rationalizing it you have to multiply with the same number in both numerator and denominator. Make sure your denominator is a whole number and then tell the answer. Make sense? How about this? What is the answer to this? Mm. Yeah, we also you know what? Okay. Did you guys get it? I think that's enough time on that. Mm. Uh-uh. I see, inside a radical you cannot have decimals. Inside a radical you cannot have decimals. It should be a proper number. Yes, Harshita. Dhruv, is that right? I am getting confused now. That seems incorrect, Dhruv. Johan, that is right. Pratika, I told you, right? You cannot have an irrational denominator. You forgot?
Mm-hmm. I'll redo it.
Correct. Shreya, correct. Dhruv, correct. Okay, let me quickly do because I want to go to fractional distance as well. So here, times square root of 2, I'm sorry, this one can be simplified, right? Root 2 divided by root 2 times root 6, right?
Miss Priya.
Yama,
Wait, did I get it right? Or who got it wrong?
Dhruv, I'm going to explain, right? You can check whether you got it right, rather than interfering. So 1 by square root of 6. So that this is an irrational denominator. Rationalize it. It becomes square root of 6 by 6. So this is your answer. Dhruv, you can check now, right? Dhruv, is that okay? No, you did not get it correct, Dhruv. Did you see that?
Wait, I got root 6 over 6.
You edited it now.
Okay.
The original answer was root 6 by 3. Pratika, yes, that's right. So root 6 by 6. Now, let's, Prisha, did you get it, ma?
Yeah, I got it.
Suppose there are 2 points, x1, y1, x2, y2. How to find the midpoint? We'll go with the formula for this one to be very quick. So the midpoint M is given by, you have to add the x coordinates, divide by 2. Add the y coordinates, divide by 2. So that will serve as a midpoint of this line segment AB. Now, suppose if you're asked to find the distance between 2 points x1, y1 and x2, y2. Let's say this is in a coordinate plane. This is the difference in their x coordinates, right? This is x2, right? So this is x2 minus x1, this distance. This distance, right? This is basically, you have to find this distance. It's the hypotenuse of a right triangle, right? So this is y2 minus y1, right? Now, how to find out the distance? You're just finding the hypotenuse, right? So x2 minus x1 the whole square plus y2 minus y1 the whole square. Any questions here? Difference in x distance square, this plus difference in y distance square rooted is your distance between the 2 points A and B. Any questions? The formula is not complicated. It is just the difference in x coordinate square, one leg square, difference in y square. Then you add both, square root it to find the hypotenuse. I'm going to move on. You guys are going to try this one. Given 2 points, you're going to find the midpoint. There are 2 points, you're going to find the midpoint. Number 1. Give answer as a fraction. Give your answer as a fraction. Similarly, find the distance. I'll write down on the board, guys. What I want, I'll write on the board. Okay. So you're going to find the distance for this one. You're going to find the midpoint for this one. You're able to get it, guys? You can send both to me so we can move on. Midpoint, you just add the two x's, divide by 2, add the two y's, divide by 2. Do you have it? I'm assuming these things are easy for those who attended summer. Maybe 23. Eta, 23 by eta. I don't know, guys. I don't think that's right. Shreya, that doesn't seem right, ma, both. What is going on, guys? Pratika, that's not right. Did I make a mistake in giving the wrong points? Distance is correct, ma, Harshita. But I don't think the midpoint is correct, I feel. Achacho. Johan, the distance is not correct, but your midpoint seems correct. Midpoint seems correct. Distance doesn't seem right. Can we go over this quickly? Prisha, are you listening, ma? Yeah. Why I call you out, you know? Some of them attended summer, but you didn't.
Yeah.
So out a lot, okay? Nothing else. Now, midpoint is this is A, this is B. Okay, this is x1, y1, x2, y2. None of you got both right. I'm a little worried. Let's see. 2, 1 by 2, minus 1 by 4. The next point is 3, 1 by 4, minus 1. What is the midpoint? You add the x coordinates, divide by 2. 2, 1 by 2 plus 3, 1 by 4 divide by 2 is the midpoint of the x coordinate. Minus 1 by 4 minus 1 divide by 2. When you add, right, both are negative points, so you have to subtract them. So here 5, 3 by 4 divide by 2, minus 1, 1 by 4. See, both are negatives, right? Minus 1, 1 by 4 divide by 2. But how will you write it out properly? So midpoint is this, but 2023. So 5 4s are 20, 23. 23 by 4 divided by 2 minus 4. So this one is 5 by 4, right? Minus 5 by 4 divided by 2. So what happens here? 23 by 8, minus 5 by 8. Any questions, guys? I know what confused you. Maybe the negative value confused you, I think. Right? So be careful. Did you get this midpoint? Shreya, did you get it, ma? Johan, did you recalculate the distance by any chance?
Yeah, I got it now. I realized my mistake.
No problem. As long as you realize, I'm happy. That's right, Pratika. Avyukt, did you understand the mistake in the midpoint?
Yeah.
I'm glad I picked out a hard question. Okay. Ananya,
I accidentally subtracted instead of adding, and then I realized at the end.
I see. See, that's when the negative points are included, everybody, it's a little tricky. Prisha, did you understand, ma?
Yeah, I did.
Okay. Now coming to the distance, what happened? I told you, right? See, when Negatives are involved, we always tend to make mistakes. Okay, jk. So I'll start with k always. Okay, the difference minus 3, subtract this minus 5. Don't worry about it, you can deal with it later. Okay, this square plus minus 2, I'll write down, subtract 5, the whole square. Now take square root of it. How do you do it? Minus 3 plus 5 it becomes the whole square plus minus 2 minus 5 the whole square. So 2 square plus minus 7 the whole square. So that's square rooted. 4 plus 49 is 53. Any questions? Square root of 53. Any questions? It can't be simplified. Dhruv, are you with me?
I got square root of 53, but I thought it would be like a whole number, so I was like, keep trying until I got a whole number. I didn't know like.
Oh, so you got it. Okay, good. So you need to be careful with the distance. Now, how about this? I have a line segment XY. This is a tricky question. I have a line segment XY. A tad bit tricky, not very tricky. I have a line segment XY. The midpoint is 3 comma minus 5. The midpoint of this is 3 comma minus 5. Now I can give you, okay, the coordinate of y. The coordinate of y is minus 10 comma 5. The coordinate of y is minus 10 comma 5. What is x? You can use the formula directly. Basically, what is usual? You put it as x1, y1. Put it as x1, y1. So, by the formula, x1 plus minus 10 by 2 is what? 3. So, like that, you calculate for y as well. Now, you have to solve this equation to find out x1 and y1. Prisha, are you following? Good. Hmm. Oh, you got it, Johan? Let me check. I'm thinking it should be too easy. Yes, Harshita, correct.
I have a question. So the midpoint is -5 for the y-axis,
Yeah,
but
correct.
y is 5 and they're on the same line. So
Okay, Dhruv, you asked me a good question. I didn't mean to put it on scale, meaning I did not put in the coordinate plane. I just told you that there is a line segment XY. You know what? If I had to draw it correctly, right, I should have drawn it like this. Minus 10 comma 5. I should have drawn y here. Wait, minus 10, sorry. Minus 10 comma 5, I should have drawn it here. Okay, that is x. That is y. And then x I don't know, but the midpoint is 3 comma minus 5. So midpoint is here. I should have asked where is x. I should have drawn this line like this. Then only it is right. I didn't do that. Does that answer your question?
yes.
I just put it out to you for you to understand, but I meaning refer to the points correctly. Y was this. Midpoint was this. I'm asking for X. That's all. Prisha, are you able to do the problem? Correct, Ananya. Correct. Oh,
Yeah, I sent my answer.
yeah. Pratika, is it minus 15 or plus 15, ma? Pratika, is it minus 15 or plus 15?
Minus.
No problem. If you get it, fine. Okay, let's move on. Okay, now, okay, how about, I would really like to give you this. Find the length. It's a simple question, but again, revision only. Okay, in this, right, there is a room, picture of a room given. Find the length and width of the bed. Find the length and width of the bed. Okay, after this, I'm going to move on. Find the length and width of the bed. And fractional distance is something we want to see, right? Okay, let me do. I don't remember how many of you remember fractional distance.
Miss Priya, I have to go now.
Go ahead.
Bye.
Bye. But do watch the recording, Shreya, before you come back. Really? Is it right of you? Let me check. I doubt. I thought that was not correct. I don't know. Length and width of the bed, right? I don't think it's right. This was one application problem, I thought, but I'll help you if you didn't get it. Johan, you have the answer? Okay, anyway, I can do it on the
Almost
board.
done.
Okay. So here, width and length of the bed, right? So basically, I'll draw a right triangle. I'll plot the points first of all. What is this? This is, let me plot the points, 0, 5. What is this point? 5, 10. So the distance is the length of the bed. So 10 minus 5 the whole square plus 5 minus 0 the whole square is what I am getting. So that is 25 plus 25. I'm getting square root of 50, but you cannot send the answer as square root of 50 because square root of 50 can be simplified. Square root of 50, when simplified, length is not 50, you have to take square root. When you have to do that, it is like this, right? So that would be 25 times 2, 5 root 2. You should have written as 5 root 2 units. That is the length of the bed. For the width of the bed, you know what I would have done? I have to plot this point, which is 8, 6. So 10 minus 6 the whole square plus 5 minus 8 the whole square rooted is the width of the bed. So 16 plus 9.
Miss Priya, that's 9-6, not 8-6.
Sorry, ma. Yes, thanks. That's what I was thinking. I'll not get a real number, a good number, 9. So 9 minus 5. What did I do, guys? 10 minus 6, 9 minus 5. 9 minus 5, 10 minus, okay, 5 minus 9 is better. That way you don't make a mistake. 5 minus 9. So this will be for 16 plus 16, 32. Root 32, I cannot express my answer as root 32. So what I do, it'll be what? Root 32 is 2 power 5, right? 2 to the 4, 4 to the 8, 8 to the 16, yeah, 2 power 5. So square root of 2 power 5 is nothing but 4 root 2 units. Got it, guys? Okay, let's move on. Do you all remember this? Let's see. Prisha, you understood, I know. Okay. Dhruv, did you get it? Dhruv, Yerevar. You got it?
Yeah, I got it.
Okay, good. Now, I want to partition the line segment in a given ratio, right? Remember, let's go over that quickly. I have a line segment, okay? A to B, A, B. Okay, partition, please, the direction is important. Line segment AB, okay, partition ray AB. In the ratio, if I give you 2:1, if I give you the points as well, you have to think a lot. See, if I partition a line segment, the ratio 2:1, I'm making how many pieces on that line? I'm cutting the line into 3 pieces because I need 3 parts, ratio, right? Total is 3 parts. So I have to find the point. You have to go from A to B. The first piece should be 2 parts. So I have to find what is this point. What I'll do for that? First, I need to find out the ratio. What is the ratio? 2 pieces out of the 3 pieces. So 2/3 of the x distance, 2/3 of the difference in x. This one will have x1, y1. This one will have x2, y2. These are the points, right? So first I'll find 2/3 of the x distance, right? And then I'll add it to the starting point x1. Here partition AB they have given, so I'm starting from A. Similarly, for the y coordinate of this point, I will again find 2/3 of the distance of the y, difference in distance of the y, and I'll add it to the starting y coordinate. So when I want to partition a line segment with points x1, y1, this A point is x1, y1, B point is x2, y2. In the ratio 2:1, let's say in the ratio A is to B. How will I write? First I'll take the starting point x1. To that, I'll add what? To that, I'll add first the ratio time. So A by A plus B times the difference in the distance of x. Similarly, for the y coordinate, y1 point I'll add to A by A plus B of y2 minus y1. Do you all remember this or do you need help with this? Prisha, are you following?
I understood the first part where you split it, but then I don't I don't get the part where you're saying 2/3 times x2 minus x1 plus x.
Johan, Dhruv, all you got it, right?
Yeah.
So basically what I'm doing here is I'm splitting up into 3 parts, right? So when you think about it, this is 2/3 of the x distance. This is 2/3 of the y distance, right? That's why I'm doing 2/3 of the difference in x distance, 2/3 of the difference in y distance for the y coordinate. I do that and add it to the starting point for each. Make sense? Now let's try this one. So AB point x1, y1, this is x2, y2. You're splitting up in the ratio A is to B. Then I'll write down x1 plus A by A plus B of x2 minus x1. Similarly, y coordinate is y1 plus A by A plus B of y2 minus y1. So this point partitions line AB in the ratio A is to B. Let's see. I'm going to give you a question. Let's see how much we are able to do. I really want to move on to that postulates and discuss the next things with you. Let me see how much we can do. Now I'm going to erase this off. How about this? Find the coordinate of point P. why are they giving along directed line segment? Directed line segment means the line segment is a direction. You have to start from A, go to B, not do the other way. If you do the other way, you'll make a mistake. Find the coordinate of the point P along directed line segment AB in the ratio 3:1. I'm going to show you first.
Miss Priya.
Yeah.
So like the ratio 3:1, is that the A and B?
Correct.
Okay.
So Dhruv asked me, Dhruv picked out correctly. So I'm going to do it correctly this time. -1, 2. This is A. B is 7, 8. So now I have to split this line segment in the ratio 3:1. So how many total parts? I need 4 parts. So that point, right, point P will be 3/4 of the x distance and 1/3 of the x distance on that side. So 3/4 of the x distance, 3/4 of the y distance I will add to the starting point. If you're getting stuck, let me know. But if you can do this, then yeah, you can go ahead. Oh, that's nice, Johan. Your last answer I just saw now. Are you all able to do this?
Yeah.
Good. If you're stuck, immediately let me know so that I'll also start doing on the board. Just find see, how will you find that x coordinate? Start with your starting point, -1. Add what? 3/4 of the x difference, x coordinate difference. X coordinate difference you find and then make 3/4 of it and add it to the starting point. Prisha, Pratika, am I clear?
Yes.
Really? I don't know the answer. Fake. Correct. Dhruv and Pratika, Dhruv and Harshita, I think you got it. I think I can check. Yeah. See, more than the ratio, I want one fraction. There's no problem on fraction. Yeah, I think we are good. If they ask you fraction, you have to apply the same fraction directly. Okay, you don't do 4 pieces. If they ask you, hey, find point P, that is 1/3 of the distance, means you have to apply the ratio directly as 1/3. That's all. If it is a fraction that they give, right, then in that case you have to apply the fraction directly. You don't find the number of pieces there. Johan. Oh yeah, okay, Johan. Guys, did you all get it? Prisha, where are we? Where are we?
I got it, but like I got the X one, but I'm doing the Y one.
Tell me the X one. That gives me confidence.
-23/4.
No. Let's see what is the mistake. So I split it up into 4 pieces, right? I need to find 3/4 of the x distance. How did you find the x distance? X distance is always ending point minus the starting point. 7 minus -8. Minus 1. Right? That I need to add with your starting point. Do you get that? So it would be 3/4 of 8 minus 1. So 6 minus 1 is a 5, right? Y coordinate would be 3/4 of the y distance. Ending point is this directed line segment. B is your end, A is your start. 8 minus 2, 6. And then you're going to apply the starting y. 2. Now this would be 9 by 2 is 4.5 plus 2. 6.5. So that P point is 5, 6.5. Can I move on? Any questions till here? A big revision. Can I move on?
Yes.
Okay, but I don't get a lot from you. Did you get it?
What did you say, me?
Yeah.
Oh, yeah, I got it.
Now let's move on to, see, in geometry, last time when I met, I said we are going to cover a lot of proofs. For writing proofs, basically we will there are 3 types of proofs. Proofs when you write in geometry. Simply I'll say, okay, I draw 2 parallel lines, prove that alternate interior angles are equal. I'll ask for any proofs in geometry. I'll draw a triangle and say, hey, this is an isosceles triangle. Prove that the 2 angles are equal. I'll ask you to prove anything. Okay, here now we will introduce you to a lot of definitions there and here. What is a postulate in geometry? Any statement, a statement is called a postulate. Postulate is also called an axiom. Postulate is also called an axiom. Okay. Any statement which is accepted. Any statement that is accepted as given is a postulate or an axiom. Okay. There are several postulates. Through any 2 points, there can be only one line. It is a statement which is accepted as is. Through a plane, we can say, let's say there are 3 non-collinear. What is collinear and non-collinear? Collinear means all points are on the same line. Non-collinear is they're not on the same line. Through any 3 non-collinear points, there can only be one plane. That is a postulate. When I say that, you accept as it is without asking for a proof. Why are we learning these postulates or axioms? These are so required to write out proofs. What is a proof? We will study 3 types of proofs. Okay. One is 2-column proofs. The next one is paragraph proof, or we'll study a flowchart proof. Any questions here? Now, in a 2-column proof, how will we write a 2-column proof? You will see statement, you will see reasoning. Statement, reasoning. This is a 2-column with this is how you write proofs. If I ask you to prove something, then you will say statement on the left side, reason on the right side. For writing out reason, you should know a lot of postulates, statements that are accepted without asking questions, you should know. So those you will write as reasons in that. Okay. Now, if I give you 2 parallel lines and ask you to prove angle A equal to angle B, what you can tell first, A plus angle C. So I can say statement is A plus angle C is 180 degrees. Why? Because this is a line, right? The reason is it's a linear pair. Meaning in the sense, see, I'm just giving you an idea. You don't have to know all this now. So when I write proofs, left side I have statement, right side I'll have reason. So you should know what to write under statement, what to write under reason. The reason column is going to have a lot of postulates and definitions. So many definitions in geometry will come across. Okay, so many theorems will come. So what is the difference between a postulate and a theorem? Who can say? What is I explained this, but I did not explain this. What is the difference between a postulate and a theorem? Both are statements. Okay, both are statements. Okay, let me give you an example and then ask you things. So I'm telling you postulate and a theorem. Okay, I said postulate is an accepted statement as is. You don't ask me for proofs. Okay, so here let's see this one. In geometry, it's interesting. only with some acceptable statements we can write proofs. Now let's say I have two parallel lines and a transversal. You all know that these two angles are equal. What type of angles are these? What type of angles are these? What type of angles are these? We have learned, right, in 7th. Guys, please try, guys. Yes.
Or are they congruent angles?
What is that?
Are they like congruent and congruent angles?
They are definitely congruent, but what type of angles are they? Do you remember corresponding angles? Do you remember learning about corresponding angles? Do you remember or no? No means no, I accept it, right? But just tell me whether you remember or not.
Yes, I remember it.
Okay. So these are corresponding angles. When you think about it, this is the first thing we know. Okay, corresponding angles are congruent. This is a postulate. Okay, postulate means we don't prove that. Okay, however, when it comes to, hey, angle 3 plus angle 4, how are angle 3 plus angle 4? Do you all remember what type of angles are they? What is angle 3, angle 4?
Same side interior angles.
Yes, consecutive, you can call it as same side interior angles or consecutive interior angle. Consecutive, same side interior angles, same side interior angles or consecutive interior angles. Here they are supplementary. Yes, yes, yes. Same side supplementary. That's how I used to explain in 7th grade. So, but then the same side angles being supplementary, right, really requires a proof. How can you prove it? You have to start from the postulate. Postulate is accepted as is. After that, only when you prove that 3 and 4 are equal, we call the same side interior angles being being supplementary, right? We call that as same side supplementary theorem. Same side interior angle theorem is what we call. So, a postulate is a statement that does not require a proof. A theorem is something, a statement that really requires a proof. Make sense?
Yeah.
Okay. That's the difference between a statement and a theorem. Now, let's go ahead and try this one. Okay. As I said, right, I, if you remember right, I already introduced you to some of this, meaning if I say x equal to 3, x plus 3 equal to 3 plus 3. If I say this in my statement, in the reason end, I can say, hey, this is addition property of equality. You just add 3 to both sides. So the reason I'll say addition property of equality, this all comes from algebra. Suppose if I say x minus 3 equal to 3 minus 3, what is this property? You're subtracting 3 on both sides, right? What is that called? Subtraction property of equality. This is how I write statement reasoning. Now, if I write 3x equal to 9, what is that called? Multiplication property of equality. This is coming from algebra. Suppose if I say x by 3 equal to 1, what is that called? Division property of equality. Any questions still here? Similarly, what else I can say? Okay. How about this? A times B plus C, if I expand and write AB plus BC, what is this called? What is this property called?
Distributive property.
Distributive property. Like this, I write reasoning. This is how I write, okay?
Priya,
So, Yama,
after this, like we're done reviewing this, I think I have to go.
sure. We'll be done by 9:10. Don't worry. 8:10.
Okay.
So when we start writing proofs, we are being introduced to a lot of postulates and we are being introduced to a lot of postulates which will serve to write the reason. Okay, writing proofs is a big thing in geometry. That's where everybody gets stuck, and I don't want you to get stuck. That is why I want to push it right away. Okay, now let's say I have this. How about this? How about this? Okay, let's say if I write 1 by 5 d BC equal to 1 by 5 DE. I'm giving you this, okay? But I say BC equal to DE. What property did I use to arrive this from this? What property did I use?
Multiplication.
Multiplicative property of equality. I multiplied both sides by 5. So see, the reasoning is multiplication property of equality. This is just a statement that you write. Okay, now let's go ahead and I want you to go over some, see every class I want you to learn something new. Okay, we revised a lot, but I really want to go over new things as well. I'm going to introduce you to a lot of definitions. Why are we learning those definitions? It's really going to serve you to write the reasoning for proofs. Okay, now let's say if in a statement, let's go ahead. Okay, let me say, if suppose, if angle ABC is a right angle, right? Then I can say angle ABC is equal to 90 degrees. What is the reason behind this? What is the reason for calling it like that? If angle ABC is a right angle, this is this. This is what you mean by definition of a right angle. Any questions here? Definition of a right angle. What is a right angle? Right angle says if ABC you call it as a right angle, then ABC is 90 degree. Definition of a right angle. Now, let's say if ABC is a straight angle, what happens? If ABC is a straight angle, then what do I call? Avyut, you tell me. Then ABC will be
180 degrees.
which is the definition of straight angles. Without this reason, we can't get into proofs. Okay, now let's try this one. If I say angle 1 plus angle 2 is equal to 90 degree. Here the sum, if I say the sum of two angles is equal to 90 degree. If sum of two angles is equal to 90 degrees. Or let me go this way. Let me go this way. 1 second, guys. So if I say, let me not do this one. Instead, let me do this one. If I say A and B are complementary angles. A and B are complementary angles. What does it mean? Anybody? If I say A and B are complementary
They
angles.
both add up to 90 degrees.
A and B, if I say are complementary angles, I can clearly say measure of angle A. This is how you read in geometry. Plus measure of angle B is 90 degrees. That is the definition of complementary angles. Similarly, if I say A and B are supplementary angles, what does it mean? A and B are supplementary angles means measure of angle A plus measure of angle B is 180 degrees. Definition of supplementary angles. Any questions still here? Any questions still here?
No.
Okay, now suppose if I say here AB, line segment AB is congruent, see the symbol of congruent, is congruent to line segment CD. Or if I say angle ABC is congruent to angle CDE. If I say that, what does it mean then? I can as well say congruent means same shape, same size. I can say AB line segment length is equal to CD line segment. Congruent means the shape itself is congruent, same shape, same size. Just because it has the same size, I can say line segment AB is equal to the length of line segment AB is equal to the length of line segment CD. So what is the reason? Definition of congruent segments. Definition of congruent segments. Similarly, if the angles are there, then I can say measure of angle ABC will be equal to measure of angle CDE. That means what? Definition of congruent angles. Any questions? We'll have a lot of definitions like this. Can I move on? Can I move on?
Yeah.
Okay. Now if I have, let's say there's a line segment AB. Okay. I say, hey, M is the midpoint of AB. If I say that, what can you say? Then AM is congruent to AB. What is that reason? Definition of midpoint. So we will cover a lot more like this. I really want to cover all. Now, suppose if I say, let's consider the line segment CD. Okay, this is OP. Suppose if I say, hey, PO is the bisector of line CD, then what can I say? Let me call this as A. I can say CA is congruent to AD. What does it mean? PO bisector. This is the definition of segment bisector. It's a segment, right? Definition of segment bisector. If something serves as a segment bisector, that means what? The left part of the line is equal to the right part of the line, right? So you call that as a definition of segment bisector. Now, there are more to it actually. So let's go ahead and see. How about this? Okay. Suppose if I say,
Miss Priya, I have to go soon.
sure, ma, sure. Yeah, you can leave. Like whenever you want to go, you leave. Similarly, for the second we did, suppose if I have the angle ABC, I cut it like this. What is it called here? Here, what can I call? Measure of ABD. Measure of ABD will be equal to DBC. So what is it called? Definition of angle bisector. Any questions, guys? Any questions? I'm going to give you notes on all these. So a lot of definitions are in here. Similarly, there are a couple more postulate. Wait. So here, let's call out this one. How about this? Suppose there is a line segment A, B, C. If point B lies between AC, then I can say AB plus BC equal to AC. What is this called, guys? We have done that in summer. What is this called? This is a postulate.
Addition postulate.
What is it?
Segment addition
postulate. Good job. You're adding segments, right? Segment addition postulate. Similarly, for angles, again, you'll have one. A, B, C. Here. Measure of angle ABC will be equal to measure of angle ABD plus measure of angle DBC. What is that called? Angle addition postulate. Any questions till now? Now, let's go ahead and try one more. Let's say a line MN is perpendicular to another line at P. AB is perpendicular to CD at P. AB is perpendicular to line CD at P. If there are two lines that are perpendicular at a particular point, right? What does it mean? APD or CPA is a right angle, right? What is the definition? Definition of a perpendicular. Definition of a perpendicular. So you should be able to differentiate when to write the reasoning as a definition or a postulate nicely. Okay, now let's finish this up with two more which are quite important. Let's see. How about this? Okay, let's see this one. I'm going to erase this off. How about this? Okay, suppose we have two line segments. Why I'm not able to write? Give me a minute. Suppose if we have two line segments, AB, CD. What do you talk about these two angles? There are two line segments that intersect each other in such a way 1 and 2 are vertical angles. Here 1 and 2 are vertical angles. What can you say about it?
They're equal.
Yeah, they're congruent. In geometry terms, we'll say they're congruent. Why? Vertical angles are congruent. The reasoning you'll say vertical angles are congruent or vertical angles theorem are congruent. You can also call it as vertical angles theorem. Okay, so that was too many definitions or postulates that we discussed now. So I want to stop here. We have more, but I want to stop here. Let's see this one. How about this? I just want you to be able to write out reasoning now. I'm going to stop this, ask you a couple of questions, then let you go. But we'll continue this next week. How about this? Oh, 1 second, guys. Why? Sorry, guys. Wait, I'm not able to. Give me a minute. Let me give you two questions and then I'll let you go. How about this? Okay, how about this? Here, this if B are supplementary angles, if A and B are supplementary angles, tell me what you can conclude. If I state the reason as, tell me what you can conclude. I'm stating the reason as definition of supplementary angles. What you can conclude? Yep. The sum, right, Johan?
Yeah.
I can conclude measure of angle A plus measure of angle B is equal to 180 degrees. So the first two, right, see, they would have given this, okay. You will write the statement as this, but your reasoning will be definition of supplementary angles. How about if I give you, okay, if I give you this, given this, what you can, given this, they've given you this, what you can conclude about this, and what is the reasoning? There's a line segment, so what can you conclude about it? Something that we discussed now, right? What can you conclude about PR? Will be the,
Wait, should we say it out loud? Or
yeah, Ma, please say it out loud. We'll finish.
that PQ plus QR equals PR.
Yeah, QR. So that is what? Yes, Johan. So that is segment addition postulate. See, the thing is, the main thing geometry kids have trouble is coming up with the reason. So this is segment addition postulate. So I know it's a little boring, but then if you are very thorough with this in these two classes, right, next to the proofs will be a smooth ride. That is what I'm intending. Okay. So now for this week, I'll get you a lot of what if then statements. You write the reasoning, or you fill in the then statement, or I'll give you the conclusion and reason, you fill in the if statement based on whatever we have read through. And I'll also provide notes. Go through the notes and fill in. Any questions? Any questions?
No.
Okay, so please fill it in and then we'll go to proof. So you will find it so easy. Okay, yeah, I'll stop here, guys. Yeah, bye, guys. See you all next week. Have a nice week ahead in school. Bye. Hey, Avyuk, you had something to discuss, huh? What was that? What is that? You got a calculator? You can't unmute, huh? Okay, we'll talk next class. Don't worry. Good job. Bye bye.